mystery device time, and even I don't know what the circuitry is in this, but I built it ages ago. It must have been inspired by a light I got from RME, Radio Mechanical Electro, on Howard Street in Glasgow, that powered directly from the mains. It charged up, and if I plug this in, the red and green LEDs glow dimly. They are the older technology, which gives a bit of the age, although I'm said that. These are white LEDs. Sadly, when I turn it on, nothing happens. But this was rechargeable. When I look at the data, it says 0.1 watt and 7 milliamps and a near zero power factor, which kind of suggests that this is probably based on a capacitive dropper inside. But there's only one way to find out, and that is to open it. So I shall unplug it. And we shall explore what's inside. If it is a capacitive dropper, I wonder if I've actually added a discharge resistor. I'll just dab that over there, just as a precaution. That's it, discharged. I thought this might have been resistor based. This was in my toolbox for such a long time as a handy little backup flashlight, and it will, from that era, be based on nickel cadmium, probably a 3.6 volt battery, perhaps. That suggests why it's not working. Let's zoom down this. Is it going to be super crusty inside? Is it going to be one of those classic battery that has splooged its fuzz out everywhere? Oh, it's the big moment. Long time since I've seen in this. Crusty battery. Okay, there's a bridge rectifier. There's some resistors. I can see little insulators I've put in. Is that a capacitor there? I think it is a capacitor. It is the capacitor. Right, tell you what. Let's see if I can gently lever bits of this out. It's glued in, isn't it? It is, it's glued in. Either that or everything has been stuck in. Oh, there's a Zener diode across this. What would that... Oh, I know what that is. That may have been to light the green LED when the thing was fully charged. Wow. Interesting. Oh, this isn't coming out. Let's explore it, and then I'll draw the schematic down. I don't think this is going to get put back together as such, because unless I could put in a flashlight, a lithium cell, should I say, out of a solar light. Oh, there's a bridge rectifier. Okay. The capacitor, I'm going to guess it's 100 nanofarad based on the 7 milliamps, but where is the rating? Oh, that's a Rapid Electronics nickel metal hydride. Oh, it's 4.8 volts. It's not 3.6. 160 milliamp power. Not bad. Not bad. Okay, right. Before I go any further, I really should reverse engineer this before breaking it apart. Is that 100 nanofarad? Where's my magnifying glass? You guys probably see it already. It's 100 nanofarad. Excellent. Right. Tell you what, I shall reverse engineer this. I will look at the circuitry. One moment, please. Okay, straight to the schematic for this one, because there is no circuit board. I'm getting deja vu. It reminds me of my trash emergency light. This is an emergency light project. It's in a video where it was designed using the Chinese principles of the absolute minimal component count. And when you plug this into charge, I shall plug it into charge. A red light lights, and the white LED then glows very gently. But at the moment, it's using a capacitive dropper with this capacitor here and this bridge rectifier, charging the lithium cell via the red LED at very low current. And then when the power fails, the main LED comes on at full intensity, or whatever intensity you choose by the components. It was a very good circuit. It worked. It had a slight Achilles heel. The DW1 protection circuit doesn't like it. It cuts out, and then it won't let you use it again until you give the cell a boost up. Having said that, if this was an emergency light, you wouldn't be storing it for long periods of time discharged. Anyway, that's my excuse. Let's take a look at the circuitry and marvel as older Clive at what younger Clive was thinking, because there's an oddity. It's that Zener diode. I don't know. It's odd. Anyway, it's a capacitive dropper. It's not got the discharge resistor across the capacitor. It's actually got it across the pins, but it has the same effect. So it's got a 100 nanofarad capacitor. I think that other one was 100 nanofarad, was it not? hold on, let me just look at that. Let me get a magnifying glass and look at this. And it says 220 nanofarad. As a matter of fact, 100 nano would have worked for this as well. That would have been that 7 milliamps, which is ample for trickle charged emergency light. So it's got that, the capacitor, for the capacitive dropper, it's got an inrush limiting resistor, good, 1K, 2.2 megohm resistor for that, anti-tingle, a bridge rectifier based on natural full bridge rectifier. There it is, there. And then it's got two LEDs in series. I thought initially one of these was assigned with the Zener diode to indicate something, but I think I just put two LEDs in because I could. Then you've got a stack of 1.2 volt, 4.8 to make a 4.8 volt nickel metal hydride battery of cells. So that can be from 4.8 volts up to about, say, 6 volts fully charged, roughly 1.5 volts per cell. Then we've got the two LEDs, a switch and a relatively low value resistor, which is pushing those LEDs hard, but it was designed for brief use as a flashlight, so to speak. If we do the mathematical computations here with the kink calculator, if that charged up to 6 volts, which it would have fully charged, it would have been 6 minus about the 3 volts, the LEDs at fairly high current. So that would leave 3 volts to drop across the resistors here. The resistor should say 3 divided by 27 equals 111 milliamps divided by 2 equals about 55 milliamps per LED. That's quite a lot for a little 3mm LED. If, however, naive or younger Clive thought the cell only charged up to 4.8 volts, it would be 4.8 volts minus, say, about 3 volts across the LEDs, giving 1.8 divided by the 27 ohms equals 66 milliamps divided by 2 equals about 33 milliamps per LEDs, which is also a bit too much. I think this was based on the fact that some of the keychain LED lights really bashed the LEDs for maximum intensity. But that's not a good excuse. That should have been a higher value resistor. Also, the LEDs are not super bright because they were early LEDs. The only thing I can think of for this oddly placed Zener diode is that maybe I meant to put it across the switch or something so the LEDs glowed when it reached somewhere above 5.1 plus 2.4. Fuck knows. I haven't a clue why I put that Zener in there. The only other thing that comes to mind is it was to protect the LEDs against electrostatic discharge or transients from the circuitry peaks. I don't think so, because certainly the LEDs at that time were failing, the early ones. It turned out that the reason they were failing, the Chinese suppliers claimed it was electrostatic discharge, which it may well have been to a degree, but mostly it's because they were out of a dumpster and being sold on eBay. They were crap LEDs, but that's okay, they were affordable. But that is it. It was fun to take apart. Will I be rejuvenating it? I could get some solar lights. I could get the individual cells out them. I could stack 3 or 4, probably go with 3 actually. And I could replace this with those and get rid of the Zener diode. But to be honest, I don't know if there's much point. There are much better lights. I mean, look what's come along since. Things like this, which have tons of light, really megatons of light, and easily recharge batteries very quickly. But there we have it. That's a sort of crap that young Clive designed to put in his toolbox for use at work. It was a very compact, direct mains rechargeable LED light with all the bells and whistles and extra LEDs on it.